I'm a third-year honors in physics and mathematics at UBC. Today's title is A Brief History of Me and Physics. And our contents will be those. Well, first one, I will give you a very brief description about myself and high school experience. And then the second one is a brief history of time. Yeah, it's a book written by Stephen Hawking that has influenced me for my lifetime. And the third one is some tips in physics. And the first three parts, I'm gonna cover that really fast. The first one is the most important one that I want to share with you. Its subtitle is called "The Must Be Shared Motivational Story that Appreciate Most in Technology." So the two stories of one is from a very famous mathematician, Andrew Wells, and one is Albert Einstein. And okay, so the first thing is that we have different, educational systems. So we got 3 years in junior high, 3 years of senior high. So all my 6 years of high school experience can be summarized in one picture with this. Yeah, so you can imagine the kind of combination in a country with a population of 1.3 billion people. Yeah, so that's all my 6 years experience. Yeah, it's done. And then, but I'm not complaining about that because it does have some merits for studying mathematics that I can set up a relatively solid fundamentals in physics, basic physics and mathematics, at least in the high school level. And the second one is cultivating some of my basic intuitions in physics and mathematics, because you do a lot of exercises on all kind of basic physics topics that you're required to do. So, and then I came to Canada and to study my first 2 years of undergraduate study at Langara College. Well, the reason why I choose to study at Langara College is to save tuition fees, because the international student tuition fees are super expensive. And I'm very confident that I can transfer to UBC because because as well as getting an offer of Langara, I also get an offer of University of Alberta and University of Victoria, but I choose there and then transfer to UBC. Yeah. And then I started my study at UBC from last year in May. Yeah. Okay, that's the second. It's a brief history of time. Yeah, this is a book that influenced me really, really a lot. When I was 13 years old, I read this book in a library. And it is this book that made me to make up my mind to be a theoretical physicist, to study our universe or multiverse, who knows. And introduced me with some very interesting topics like black holes, like elementary particles and their interactions, like space and time, and stuff like that. And then, yeah, you can just read a little bit. Yeah. So fell in love with those topics and got pretty good grades in physics and mathematics at high school. And the funny thing is that at 14, because I read that book, Brief History of Time, many times, and I thought about and then there was an article competition to meet, and I thought maybe I can read for that. And as a child, I saw that maybe the universe came from a super big black hole, because that satisfies the condition of conservation of energy and charge, and more importantly, it explains why our universe came from a Big Bang in the first place, because it comes from a black hole. Well, that's what I saw as a child at 13, and absolutely I got rejected for that competition, because the kind of articles they require is like how a hero in Chinese history have influenced me. It's that kind of article like that. So, but anyway, I was really interested in those topics when I was a child. And then I choose major study university transfer physics program like Arago, competitive. Oh, that's a requirement that you need to satisfy. You need to have a very, very competitive GPA in order to get in the honors physics mathematics degree. And then, yeah, that's currently I was working with my partner under the supervision of a postdoctor at Triumph. We are working on low energy unification of gauge couplings. So gauge couplings basically, maybe you know that there are 4 kind of fundamental interactions in nature. So gravity, the electromagnetism, the strong and weak interactions. Well, let's firstly, besides gravity, those three kind of interactions can be described by something called gauge couplings. It basically determines the strength of the forces. But these forces are not constant. So at different energy scales, the strengths of interactions are different. So basically, there is a theory called supersymmetry. It said that at the beginning of the universe, when the energy is so strong, these three kind of interaction forces are basically from one force. So as energy cools down, so the symmetry breaks. We call symmetry broken. And then we got three forces. So supersymmetry tells us maybe those three kind of forces are actually one force at the Big Bang. Well, and our project is about but supersymmetry happened at a very high energy level. It's about 10 to the power of 13 TeV. That is a very high, energy scale. Human beings will never be able to build such a huge particle accelerator in order to test this theory, because the size of the accelerator by that time will be as large as our solar system. So you are not going to build that accelerator to test that. So our project is on a low-scale unification. That's very interesting. You can test that theoretical difference between supersymmetry and our theory at a low energy scale. Yeah. And another thing, last summer I published an article from a sphere R3 to Earth for mathematical space-time. But also basically is that I use sphere as an example to illustrate how the geometrical properties of sphere can help us understand the property of curved space-time. Yeah, and then most of the time I spend most of my spare time to self-study the other general relativity and quantum field theory. Okay, let's proceed. Jump that. I will talk about the most important one first. Yeah. Well, that's the thing that I really want to share with you. So these two stories has inspired me really a lot. The first one is phrased as calculation of the century. The second one is phrased by Bohr, a quantum physicist, as the greatest accomplishment of human thought about nature. The first one is about the proving of Fermat's last theorem in 1995. An arduous 9 years work, a straight 9 years work by Andrew Wells, a British mathematician, and Albert Einstein general theory of relativity. It took him 8 years to completely finish this work. So about the Fermat's last theorem, do you guys know the mathematician Fermat? You may have heard him. So he wrote a lot of notes in his margin, and about Fermat's last theorem, he wrote something like, well, I got a perfect proof of that, but the margin is just too narrow for me to complete the proof. And then in the later hundreds of years, all mathematicians have tried the problem, but they failed. It's the most complicated mathematical problem in history. And when Andrew was a child, he at the age of 10, he passed by a local library and read that problem. And he was very curious about that, because that's a so simple problem that a child could understand, but no mathematician could solve it. So the Fermat theorem basically said that x squared plus y squared equals z squared, right? The Pythagoras formula. Yeah, but that's only for the power 2. And what if we got x to the power? Oh, okay. So so starting in 1986, when he was already a doctor, he started that problem, and then it took him 9 years to totally finish that. Well, in the first 7 years, he isolated himself in his study. So he basically just to find effective ways to tackle that problem. It took him the first 2 years to find a strategy, possible strategy to do that. And then, what I want to say is that it really took a great persistence and passion in science that can make you to achieve your goals. And the second one is Albert Einstein general relativity. Well, in 1905, he published special relativity, and then some physicists asked him questions about the real meaning of special relativity, and then he gave some further explaining. During that time, he realized that there is a defect, a huge defect in the theory that it only deals with reference frames, inertial reference frames. So it does not include gravity. So he made up his mind to tackle the gravity problem, to tackle the Newton's world. And then he set up his journey in that theory. And it took him 80 years to finish the general theory of relativity. So both of these two theories, both of these two stories inspire me really a lot. That I share with you that if you want to really achieve something great in science, you need that persistence and passion. I think that's the most important thing that we need to, constantly tell ourselves. Okay. The most important part is that. So some tips. Well, you need to, doing more exercise is really needed. So until you really know how to solve a typical kind of question in physics and math. And second thing is summarizing. So during our high school experiences, we basically have lots of notebooks. It's all about the summarizing of how to solve this kind of problems, what kind of techniques that you can use. Yeah, so I think if you do that, it will help you a lot, especially for those kind of common mistakes that you always make in high school physics and math. So you summarize them and you get really familiar with them. And the third one is memorization is very necessary. So some people say that keeping those stuff in mind is not helpful, but I don't think so, because it's a really important cultivation of intuition. So you saw this equation, EMF over R squared equal MA equal MB squared over MR omega squared. That one. So that's if you do some basic memorization, so you can get a pretty good intuition about basic physical laws that you can apply to new problems. So that is necessary. And the second reason is because it really helps in exam. You can finish exam really quickly and effectively without making many mistakes. So that's it. Okay, yeah. Thank you very much. One last thing to emphasize is that two inspirational stories that I really think it took a great persistence and passion for you and for us to achieve great things in theoretical physics and mathematics. Thank you.